All right. So, homework assignment. Pretty easy. So this should have been an assignment that made you, forced you to at least think for a few minutes about how am I going to solve this. Um, because I did go back and make it a little easier rather than have you collect all the hands that it could possibly be. I said it's just the best hand that doesn't go over 21. Okay, so that's a not necessarily significantly dissimilar, but you're only having to solve one part of the problem rather than also fill a collection. So let's look at that. So our job was we needed to go from having so let's do calculating blackjack hand. All right, so the number cards have their face values as values. Let's call them royalty cards. So Jack, Queen, King. These guys have 10 as their values. And then aces, and this is the question mark, right? Aces are either 1s or 11s. So now one piece of information here that is handy is that an ace is always at least 1. It's always at least a 1. So if I had a hand like a 2, king, ace, this guy has two different values, right? It either has a 13, or, so that's a 10 plus a 2 is 12, plus a 1 is 13, or it has a 23. So our program in this case should return a 13 because it's the largest value that does not go above 21, right? Now, what if I had a second ace in my hand? Because this is a 12, a 13, a 14 potentially, so this is a hand that actually could exist. You know, if somebody was like, look, I'm not going to win with a 13, and I'm over otherwise, so I'll go ahead and take another hit. I'll take another card, and I get another ace. So this guy now has a 14 as a minimum, right? A 24 as another value, or a 34 as another value. And obviously the 24 and the 34 are problematic. But an ace is always worth at least a 1. And then the number of aces that you found give you an opportunity to tack on 10, an additional that many times. So if I were to go through here, I notice I have 2 aces. So I can potentially add 10 to my total twice. Right? Each one of these aces is guaranteed to give me at least a 1 in terms of value. But then there's a potential for an additional 10 points. And with 2 aces, that means I can potentially add 10 2 times, 20 total, right? So first, come up with minimum value. So the minimum value for this hand will be a 2 plus a 10 plus a 1 plus a 1. Okay? So that's 12, 13, 14. That's my minimum value. Then, potentially add 10 to my running total up to number of aces times until let's say as long as I will not exceed 21. So I can spin through in this case 2 times. maximum of 2 times. And I ask myself, will adding 10 to 14 make me exceed my total? It will. So I'm not going to add 10 to that. Spin through a second time. Will adding 10 again to my current running total, which is still a 14, make me exceed 21? It will. I'm not going to add 10 to that. I fall out. My final value is a 14. Does that make sense? Is that the value for that hand? A 10 plus a 2 plus a 1 plus a 1? I couldn't have made one of these guys an 11. It would have made it too big. I couldn't have made both of them an 11. It would have made it too big. But do you see how I separated that idea of a 1 or an 11 into here's the minimum value that it's going to be worth? It's going to be worth at least a 1. So I can go ahead and tack those 2 1s on right off the bat. And then I could potentially add 10 2 times in this case. Does that make sense? So I need a couple of different pieces of information here. So first of all, I'm going to need a way of counting how many aces are in a hand. Easy enough? All right, so let's write a function that does that. Counts number of aces in a hand. All right, so I'm going to def count aces in hand. I'm going to break this down into little tiny steps. So I'm going to write this. I mean, we could do this all inside of one function, but I'm just going to write a little function called count aces in hand. That takes a hand as a parameter. And right now a hand is just a list of cards, or a list of card face values. So strings, like the string 2, the string 3, the string J for Jack, string A for ace. All right, I haven't found any aces yet, so I'm going to set my count to 0. I'm going to go through every single card that's in this hand, every single element of that list. So for I in range, we could have done it for, well, here, I'll do it two different ways just to show you the options. For I in range 0 to length of hand, each time through, I'm going to ask the question, if hand at bucket I, that's the current card I'm looking at, if that guy is equal to an ace, count is equal to count plus 1. I'll do that for every single card in my hand. In the end, I'll return count. All right, so this little function goes through and it counts the number of aces that exist in this list that is our hand. So if we had this example that I showed you here, my hand looked like this. This is and actually it looks like this. A bunch of face values. Okay, so each time through I'm saying, so this guy has a length of 4. Is the string 2 equal to an ace, to an A? No. Is the string K equal to an A? No. Is the string A equal to an A? Yes. Count equals count plus 1. Is the string A equal to an A? Yes. Count equals count plus 1. So when all is said and done here, count started off at 0, but when I go to return it, it's now going to be a 2. Go ahead.
Regarding that E, did you put in double quotes?
You can do it. It'll work both ways.
It's all working both ways?
Yeah. It'll be treated as a string type. So in Python, characters are considered string types. Yeah, so you can kind of use them interchangeably. It would not have made a difference here. But if you want to have more than one character, you definitely need the double quotes. So if I was comparing this to Apple, actually in Python this is allowed. It'll allow you to treat it with single quotes around it as well. So I would say in Python they're completely interchangeable, single quotes and double quotes. I would say just be consistent in your code. All right, so if I'm looking at an A, add 1 to my count, ultimately return my count. I'm going to get rid of all of this stuff here. So first thing I want to know here is how many aces are there. So I'm going to say number of aces is equal to count aces in hand, and I'll pass it the hand. So now I know the number of aces. And if I want to test that, I'll go ahead and print out number of aces. I'm going to stop printing all of these guys. And I'm going to actually force a hand into this. So I'm going to say get value of blackjack hand. But I'm going to pass it this hand. Which we know should give us a 2. Correct? For number of aces, and then we're printing it out. We expect this guy to give us a 2. So there's our 2 for number of aces. If I go and change my number of aces down to a 1, now it gives me a 1. If I change it to 0, now it gives me a 0. All right, so we've created our own little home recipe for given a hand, how many aces are in that hand. All right, now I need to be able to convert between something like this and its numeric equivalent, right? So a 2 should be a 2, a 3 should be a 3, a 5 should be a 5, a K should be a 10, a Q should be a 10, an A should be a 1 in our world right now. We're always going to assume the minimum for aces, like we talked about a few minutes ago. Okay? So I'm going to need another function, def convert card to value, something like that. All right, we're going to take just to remind us that it's a string representation of a card right now, I'll make my variable name card string. Okay? Because we're not dealing with card objects yet. We will be shortly. We're kind of trending towards that. But at this point, we're representing our cards as just strings. All right? So I want to know, given this card string, and this guy could be the string 2, the string 3, the string 4, the string J, the string Q, the string K, the string A. Those are the possible, and I left some numbers out of there, but those are the possible values for my cards. So I want to return here the value for that particular card that was passed in. All right? So if it's a jack, a queen, or a king, it's going to return a 10. All right? So we can either ask this inside of a single question or we can ask 3 separate questions. You might choose to ask 3 separate questions just to keep it clean. And then if you want to convert it to an easier thing, we can. Just before I go any farther here, I just want to show you the alternative to doing it this way. I mentioned when I was writing this, I would show you an alternative way. You can say for, I'll spell it out here, for card string in hand, if card string is equal to an A, count is equal to count plus 1. These two loops will accomplish the same thing. This loop here takes I on a voyage between 0 and the length of hand minus 1. This one down here says, I have a variable called card string. This guy will be equal to each individual value of hand each time through. So the first time through, card string will be equal to whatever was at bucket 0. The second time through, it'll be equal to whatever was at bucket 1, whatever was at bucket 2, whatever was at bucket 3, so on and so forth. So notice here, I'm just saying is card string equal to an A rather than hand at bucket I. So doing it this way, we no longer have to index it. We don't have to say, give me the value at that bucket because we already have that value. But what we've lost in this version of it is we no longer know where we are in the hand. We don't know if we're at bucket 0, bucket 1, bucket 2, so on and so forth. In our case here, we don't need to know where we are. So we might say the more correct, the more efficient solution, something like that, is this one. But this one worked perfectly fine. So if you feel very comfortable having collections of things and then it's always saying this particular bucket in that collection, I want to know if it's something, use your 4i in range version of your loop that takes you on a numeric voyage between 0, 1, 2, so on and so forth, and then just use that number to access individual buckets of your collection. If you like that, if you're comfortable with that, and you don't want to have to jumble your mind with extra stuff, you never have to use something like this. I'm never going to take points off if you use the wrong correct loop. In fact, you could probably make an argument that this is the correct loop. Even in this case, we don't need to use the value of I. We don't need it other than just indexing where we are. So you might as well have done this, but pick your poison. All right? And this kind of goes back to something I've been reiterating. Don't try to be fancy. Get a correct solution that makes sense to you rather than coming up with some sort of shiny Ferrari of all incorrect solutions. Make sense? Okay, so a few minutes ago, I'll go ahead and get rid of this. We'll just leave it in our stock one up there. I mentioned that we're inside a convert card to value. We're specifically interested if we're looking at jacks, queens, or kings because we want to treat all of those as a value of 10. We can ask that in a single question, or we can just as easily ask it in 3 separate questions, which is probably going to be cleaner for most of us right now. So let's ask it in 3 separate questions first. So we have a single card string that's being passed in here, so no loop. We don't need to go through a collection. We're just saying this one guy that I was given, what is his value? So we're going to ask the question, if card string is equivalent to a jack, return a 10. Else if card string is equivalent to a queen, return 10. Why isn't it kicking it? Oh, no. I know why it's not kicking it over. Still out of it. Else, card string is equivalent to a king. Return 10. Now, we might say, here are 3 separate questions that all return the exact same value. So we could have said something like, if card string is equal to J, or card string is equal to Q, or card string is equal to K. If any of those are true, return a 10. Go ahead.
Could we just say J or Q or K, or do we have to put card?
Yeah, see, that's a common mistake. You cannot just say or Q or K. Yeah. There is a... Yeah, so what she's saying is, I'll just write the incorrect thing. So she's saying, can you do this? That's a common mistake. Or is a Boolean operator that says, here's a Boolean expression, here's a Boolean expression, here's a Boolean expression. Boolean expressions are expressions that boil down to a single value of true or false. That guy boils down to a Q, not a single value of true or false. So it's obvious when you evaluate it, but as a human being, you look at this and you kind of know what you're saying here, right? So probably the equivalent of this for your world would be this kind of thing. If card string is in Jack, Queen, King. That thing. And let me show you this real quick. All right, because we've seen the in keyword. We've seen lists. We just haven't really directly worked with them together. If you remember way back when we first introduced a loop that looked like this, I mentioned what range does. Range creates for us a collection of the values between 0 and the length of hand -1. It generates that for us. All right. So when we're saying I in this, so I'm going to just go out to Python here. So I'm just at the interactive guy here. So I'll go ahead and just say list is equal to, we'll have our Jack, Queen, King, like that. So then I can just say list, and that shows me I have that guy. All right. So now if I say, I think it'll work like this. Yeah. So Jack in list, it is in that list. True. Boolean expressions, any expression that boils down to a single value of true or false, it is true that this string is contained inside of this list. King in list, 10 in list, false. That make sense? Okay, so we have that that thing, and what I'm saying is, what you can't do is this. Pretty positive this doesn't work. Range 0 to 10. What I'm telling you is that range 0 to 10 produces a list that'll be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me do it this way, actually. Plus 2 is equal to range 0 to 10. Yeah, I think it stores it as a function. So this guy does not get evaluated till we're actually ready to look at it. But I can do this. I can say 3 in range 0 to 10. This should work. It's true. So when we use the range function in conjunction with the word in, the keyword in, the range function evaluates and gives us a list containing 0 to 9. So at the end of the day, all along, we've been using the in keyword with a list. We just didn't think about it that way. Okay? So that's why things like this will work. I created a list that I'm asking a question. This is a Boolean expression. Is J in that collection? All right, does that make sense? Now, that doesn't mean we have to write it this way. This is just as correct. A little bit longer-winded, but if you like the structure of this, and you're saying, look, computers are fast. The whole reason we're becoming computer programmers is we want to leverage how fast this guy is. Because he's faster than us by a zillion times on his slowest day. And we're trying to create his slowest day here, right? This is a sprinter. We've tied his shoelaces together. We've done all sorts of stuff, but he's still fast. All right? There's nothing wrong with this. Don't be ashamed of writing this. Okay? Because if you write this and get it correct, and somebody else tries to be all fancy and gets it incorrect, oh, would you rather have a really fancy car that doesn't start, or a jalopy that gets you to work? Do they still use the word jalopy? Is that a thing anymore? Is it a what? No. Jalopy means like a piece of crap, a junky car. Jalopy, it's probably from the, I'm guessing probably the 50s, something like that. 40s. Most of you probably have heard it, right? Because most of your parents are my generation. So I might be a little older, but regardless, ballparky. So I learned it from my parents. They learned it from their parents. They passed it on. All right, so don't be ashamed of writing inefficient, correct code. You want to ask 3 different questions. Is it a jack? That means it's a 10. Is it a queen? That means it's a 10. Is it a king? That means it's a 10. Go for it. Okay? Don't throw yourself a loop trying to be fancy. All right. Then we have an else if card string is equal to an ace. And we've decided we're always, in this case, going to treat aces as ones, right? Because we've already made we have our backup plan for aces. We've already counted how many aces we have in our hand, so we can go ahead and through and see how many times can we possibly tack on an additional 10 for winners, all right? So for this guy, aces are always ones. So we'll return a 1. Else, if it's not a jack, a queen, a king, or an ace, it must be one of those faces that are numbers, right? That means we can return the int version of card string. We can go ahead and just convert them, right? But hey, if you didn't think of that, you can say else if it's a 2, return a 2. Else if it's a 3, return a 3. Else if it's a 4, return a 4. Blah, 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 blah. Go ahead.
Why wouldn't you, at the start of this function, why wouldn't you do like a for loop to have it go through every single character?
Well, this guy is just a single card, not a collection.
Oh, okay. So you're just passing it.
Yeah, so examples of what card string could be are things like this.
Okay.
That's what card string is. It's not. Yeah, right. I'm saying I want to convert a card to a value. So you're not wrong. If you wrote your function with the assumption that we're taking in a whole collection, you can't. I just wrote a single function that says I'm looking at one card. You hand me one card, and I'm going to tell you what this guy's worth. And we're going to use that guy inside of this function. Make sense? So this is us breaking things down into those smaller pieces. But this is just because how I decided to solve it. By saying I want a little helper that I can hand him one card and he spits a number back at me. Okay, so are we cool on this guy? You probably should be comfortable with this int version of things by now. So if you really felt like you had to write the zillion if statements for 2 through 10, it's not the end of the world. That's not that many if statements. But if you're writing more than 10 or 12 if statements all on numeric values, you probably want to up your game one level, okay? That's the difference between like riding the bicycle to work versus driving the car, completely disregarding health. Just, it's all about convenience. All right. So questions on this function here. That guy goes through and gives us a numeric value.
So we're just returning the values.
That's it. That's all this guy does.
Okay.
We're not solving the whole problem yet. I'm handing you a playing card, and you're spitting back to me the numeric value of it. If I give you a 4, you're saying it's a 4. If I give you a king, you're saying it's a 10. If I give you an ace, you're saying it's a 1. For right now, aces are always 1s for us in here. The minimum value that an ace can be. All right. So now we have a couple of our tools from Home Depot. Well, we didn't get these from Home Depot. We scrounged around at home with the tools we already had. We didn't invent anything new here. All right. So just so I don't forget, let's go ahead and throw that in keyword into our notes. Now that we've kind of recognized that it's actually a building block for a Boolean expression. I wouldn't, it is important in that we use it often, but the way I used it today with it as a Boolean expression, you could probably get through life without ever using it that way. Yeah, just like if you're building a house, you could probably get through life without ever using a table saw. Makes life a lot less convenient. You don't want to sit there with a handsaw all the time, but you could. You could get through life that way. So the in keyword. Whatever. So I'm just going to use it as our example from our cards. That's probably the easiest way. So ace in collection, jack, king, well, whatever. I don't have to do the right order, but I will. Produces the false. Q in that produces a true. 3 in that produces a false. So it's a Boolean expression builder used in conjunction with a collection type. That makes sense? Go ahead.
So could you have used a while loop for the second expression Q in the list? Could you use the while loop to then assign that to a 10 automatically? Because it's technically.
Which one? This guy.
I know, if you go back to the slide. Sorry. So the second Q N J Q K. If you could you use a while loop to then assign that to the value of 10 since that's outputting true? You know what I mean?
Well, yeah, you could, but you wouldn't. You mean this guy would change though inside the while loop. So yeah, you could have this guy in a while loop where for each element of your hand is this guy in this guy. If so, return whatever the value is. Absolutely. And we've been doing that. We've been doing for loops using in range for forever, right? Which is use this exact same thing. What we're looking at here is like what range gives us. So range 0 to 10 ultimately gives us that. So when we say for something in that range, it gives us that guy. All right. So we have our number of aces. We have an ability to get our card value for an individual card. So we're going to need a current hand value. And before we've looked at any cards, our current hand value is a 0, right? So we want to go through each element in this hand. So again, we can go through and we can say for I in range 0 to length of hand, current hand value is equal to current hand value plus convert card to value hand at bucket I. So this is going to go through, this is going to take I on a voyage between 0 and the length of hand minus 1. And each time through, we will call convert card to value on that particular card, the one we're currently looking at. Alternatively, we could have said for card string in hand, current hand value is equal to current hand value plus convert card to value card string. These two loops do the same thing. One of them gave us numbers that we then used that number to extract a card. The other one just set the string equal to the cards as we went through it. Pick your poison. Just know that if you're using the numeric version, you probably need to then use that number to go and retrieve a value from the list at that position. Actually, let's, just so you have an example in your code of the other one, we'll use this one. All right, so this is going to go through our entire hand and add up the minimum value our hand might be worth. Okay? So when we come out of that for loop, we now have the minimum value our hand is worth. Aces might make a difference. So now, I want to go through my number of aces, because that's the number of potential times I can add 10 to my list, or 10 to my running total, and add 10 as many times as I possibly can without going over 21. Go ahead.
I think you could, am I wrong to say that you could only add 10 once?
That's probably an accurate statement, but in that case, what you've had to do is you've had to think ahead mathematically about the game of blackjack and what are the possible hands you can have, right? So with that in mind, you would never be able to add 10 more than one time. So you could just ask a single question. So what he's saying is you could just do this. If number of aces is greater than 0 and current hand value plus 10 is less than or equal to 21, then current hand value is equal to current hand value plus 10. Regardless, return current hand value. We may or may not add 10 to it here. And we're only going to even try to add 10 if our number of aces is greater than 0. If I have some aces to work with, and adding 10 to my current hand value gives me a value that is less than or equal to 21, go ahead and do it. Otherwise, don't touch your current hand value and just return it. This here requires you to have done the thinking through the problem of blackjack and think, is it even possible to add 10 more than once? And it's not a long shot to say that that's not that hard to come to that conclusion, right? But it will not be incorrect for us to do. Let me just show you the alternative to that. For I in range 0 to number of aces, so I'm going to potentially do something 2 times. If current hand value plus 10 is less than or equal to 21, current hand value is equal to current hand value plus 10. And we'll do that up to number of aces times, and then we'll return current hand value. Pretty good chance we're going to be spinning through here. If we have more than one ace, we'll be spinning through an extra time completely as a waste of time. But this version of it, we did not have to consider whether it's even possible to add 10 more than once. We just said, look, I'm going to try. You had this many aces. I'm going to spin through and I'm going to say, will adding 10 put me over 21? If it does, I won't do it. Then I'll spin through again and I will not do it again. Does that make sense? So either one of these is fine. The loop is probably the simpler solution that doesn't make you think about the problem you're trying to solve. We're just saying, look, I can potentially add 10 to my hand value total, my current hand value, number of aces times. And even though mathematically we could never do it more than once, I'll try. Who cares? I'll spin through. Can I do it? If yes, I'll do it. If no, I won't do it. If I spin through again, I'm going to ask the same question again. You might be getting tired of me asking the question because it was wrong last time. It's going to be wrong again. I won't add it again. We fall out of this for loop, and our current hand value is whatever it's going to be. We either added some 10s or we didn't. And for loops are pre-check loops, which means that if number of aces was 0, we will not execute the body of this loop even one time. So we're only going to even possibly do this logic in here if number of aces is at least 1. All right, that makes some sense? Okay. So let's go ahead and let's print out a couple of these guys. Notice here I'm returning current hand value. I'm not printing it. I'm just going to print it out here, proving what we're getting here. So a 2 and a king is going to be a 12. A 2, a king, and an ace should be a 13. So let's give ourselves a 2, a 7, and an ace. That's a 9. That'll be a 20, right? Here, we'll give an 8. Give ourselves a blackjack. All right, so I'm going to pass it a couple of different hands. Oh, I need to quit out of this. For those of you who've had messaged me and asked, if you're in the emulator like this, where you can just, your interactive thing, you type quit. It's the function quit, and that will bail you out of it. All right, so now you're back at the command line. Uh-oh. Oh. What's wrong with this line right here? Forget about the return. What's wrong with what I have written right there? Yeah. This is how we index this is how we index elements of a list. I want to call the int function. Okay, so as we start introducing new tools, we get new symbols that we can introduce into our error proneness, right? So this is the int function, parentheses. So there's our 12, our 13, and our 21. All right, so for next time, now that I'll give you this code as a starting point, since now we have the ability to get a hand. Yeah, see, I messaged you last night at 10:06 p.m. letting you know I was probably going to be here today. All right, so let me add this code. Blackjack hand value. So for next class, we're going to write a single player version of Blackjack, where you are initially handed 2 cards. So when you play Blackjack, they give you 2 cards. And keep this simple. It's not like some casino games where they give one face down and stuff. You get the whole hand. Here's 2 cards. And then you get to say, hit me. You get to ask for an additional card over and over and over again until you bust, until you go over 21. Make sense? So it should allow you to continue to ask for more cards until you say, I don't want any more, or until you've gone over 21. All right? So just the mechanic of dealing an individual player card after card after card on their command until they've gotten card values that go up above 21, or until they say, no, I'm good. Because like if you're playing Blackjack and you're at like a 19, you're probably going to say, I don't want any more cards. I'm going to go with that 19 and see how it goes. If you've never played Blackjack before, just do a quick Google search. There's plenty of little Blackjack simulator games out there. But the goal is you start with 2 cards, and then you can ask for as many cards after that until you've gone over 21. Okay? So we're just writing that one mechanic. And then the next step is we're going to bring in multiple players into our Blackjack game. All right? But for this assignment, just the mechanic of allowing one player to sit there and say, hit me, hit me, hit me, so on and so forth. Questions, comments, concerns, bribes? Yep.
For that greater than or equal to, does it matter if the greater than is on one side or the other?
Yes. Yeah, the greater than has to be first and then the equal to. And once again, unless I take a horrible turn, I will be here in person on Wednesday.